Okay, today we're going to do a quick little video on how Anthko's theory of time relates to black holes. The current theory is that gravity within black holes is so massive that everything is sucked into a black hole and nothing can escape because it can't overcome the effects of gravity. Anthko's theory of time doesn't totally negate that, but it does tweak it a little bit. And here's how. Within the accretion disk, uh, temporal quanta start to become much more densely packed. As they become much more densely packed, it actually slows the flow of time because time can't move because it keeps bumping into other time. Temporal quanta are so densely packed, it's like ice. Particles in ice, water particles in ice can't really move, whereas in open space it's much more like water. So that slowing of temporal quanta, that packing of temporal quanta slows time, which accounts for the time dilation we see in the accretion disk as it reaches the black hole horizon. And then we also see another interesting phenomena, which is the tearing apart or destruction of things as they reach that black hole horizon. This is also accounted for by Anthko's theory of time. Because time particles, temporal quanta, according to the theory, are so densely packed, they interact with physical matter, the things we see, touch, taste, feel, much more frequently, and this causes those things to decay much more rapidly, exponentially more rapidly, which is why we can see universes being torn apart, supernovas, and things like that in event horizons, or I apologize, in accretion disks as they reach the horizon of a black hole. And the reason, according to Anthko's theory of time, we can't see light or anything else exiting the black portion of the black hole, partially due to gravity, but also because temporal quanta are so tightly packed that not even a photon can escape that portion of the universe before it is decomposed, meaning that the density of temporal quanta in that portion of space causes photons to travel so slowly and to decay so rapidly that they essentially die before they can escape the black hole. Now, if we look at the inverse in open space, Anthko's theory of time suggests that temporal quanta are significantly lessened in open space, which means the effect of them, in layman's term, aging, would be greatly reduced, which means humans could live exponentially longer in open space. What it also suggests is that the passage of time happens much more rapidly. And which means we could travel in open space theoretically much more quickly. In fact, so quickly that potentially from a frame of reference such as Earth, which is enveloped by a viscous temporal solution, it may look like things in open space are actually traveling faster than the speed of light. Of course, here on Earth, we don't actually have any way to observe things that travel at or faster than the speed of light, or nearly as fast as the speed of light. Although there has been some studies in some deep underground research facilities throughout the planet that have discovered particles that allegedly travel faster than the speed of light, and they're trying to determine whether they travel interdimensionally or not. My suggestion is that no, they don't travel interdimensionally. What happens is they actually, in some cases, negate the effects of time and are able to travel through the viscous time solution in ways that we don't understand or comprehend at this moment in time. So there's how black holes are described from the lens of Anthko's theory of time.